Good morning friends, welcome back to our channel Unacademy GATE CE. I hope you all are doing good. Welcome back to our channel. So let everyone join first. Let everyone join. Myself Chetan Sir, as you all know now. My best GATE rank is already rank 55. I am an expert in GATE, ESE, SSC, JE and various other exams. And I have pursued a master's from IIT Roorkee. My best GATE score is 902. And my teaching experience in GATE industry is more than 3 years. Okay. Am I audible? Audio video is fully clear. Kindly comment. Good morning, everyone. Good morning, everyone. And you all know the advantages of plus till now. Yes. Good morning, Sagar, Malaya, Manish, everyone. Good morning. Good morning. So let's proceed. So yesterday we were discussing canal diversion. Okay. Yesterday we were discussing canal diversion. Till now we have reached where? Till now we have reached where? We have covered, I guess, C. Okay, see here everyone. Till now we have covered all these 5 chapters till canal design, Lacey Kennedy, waterlogging requirements, soil moisture relationship, methods of irrigation, types, everything we have done till now. Okay. Now we'll be covering canal diversion headwork today. We will finish this chapter, canal diversion headwork. Okay, we are already completed this almost. Only Kosa theory is being left. Then we will move on to canal regulatory works and then cross drainage. Okay, and then we will cover dams. Okay, so let's move on. Today we will finish canal diversion headworks. Now I will finish canal diversion headworks today. Okay, so let's move on and finish that. So yesterday what we read, there are two types of canal headwork. There are two types of canal headwork. One is your storage one and other is your diversion one. In diversion one, what you do, you store water, you store a lot of water behind the dam, which is called as reservoir, and then divert a lot of water from there. Okay, so storage is also there and then diversion is also there. So that headwork is known as storage headwork. Okay, in which a dam is constructed across river. But the next one is your diversion headwork, in which what happens, we construct a weir. Okay, we construct a weir or barrage, as I already told you yesterday, which raises the level of water behind it. Ponding is done. Ponding, okay, ponding simply means raising of water. Ponding means simply raising of water, and then this extra water and then this extra water is diverted into your canal. Okay, and then this extra water is diverted into your canal. Then we understood each and every component. Of your canal diversion network. I hope you all remember everything. Okay. Just quickly take a look of every component. Okay, so these were bunds, these were guide banks. The function of them was to simply guide flood water towards the weir. This is your main weir. Okay, you have to remember this weir. This is very important. Then this is your divide wall. As I already told you, divide wall is extending more on the upstream side. It is extending more on upstream side, as you all can see. Okay, why? Because it is creating an approach channel. Towards the canal. Okay, this is your approach channel towards the canal. You will not construct divide wall on that side. Divide wall is constructed this side. Okay, where canal is off taking. Why? When approach channel is there, water becomes still, water becomes quiet. Okay, and in this channel too much of silting takes place, and that silt is scoured off with the help of under sluices or scouring sluices, which are provided at the bottom of the weir, near the floor of the weir. Okay, and from here scoured silt, all the silt gets scoured off and comes out on downstream. Okay, this is fish ladder, you all know, for ascending of fishes. Then this is your canal, which is of taking. Silt excluder is there on the river bed, not on the canal bed. Students are generally misguided that silt extruder is on canal bed, but it is not. It is not so. Silt extruder is on river bed. River bed. This is your river. This is your canal. Okay. And silt extruder. This is your silt ejector or extractor, which is provided some further downstream in the channel, further downstream in your canal, and this is to remove the silt which has already entered the canal. Okay, which has already entered the canal. No problem. So all these you remember. Then we understood the diagram of weir, what was barrage. When ponding is done with the help of concrete floor, raised concrete floor, then it is a weir, and otherwise it was a barrage. Otherwise it was a barrage. And what we tried to achieve yesterday, that sir, length of pile should be more, length of floor should be more. Okay, width of floor you all can say. Then when this length will be more, then your then your hydraulic gradient, okay, then your hydraulic gradient will be less, and obviously when hydraulic gradient is less, then this seepage force, then this upward seepage force is also less. You will study all these topics in soil. Okay, you will study all these topics in soil in depth. So this is the thing. Okay, and here we provided inverted filters so that soil is not eroded, because if soil will get eroded, a pipe will get constructed. And you all know yesterday we discussed two failure problems were there. Okay, yesterday we all discussed there were two failure problems. What were those problems? What were those problems? Those were seepage and uplift pressure. Okay, seepage failure is very disastrous. It will fail your foundation which is beneath the floor. Okay, it will fail the foundation which is beneath the floor, and entire weir, okay, entire weir will collapse. So you can connect with this. And how to reduce this, we already discussed that you have to provide piles, okay, so that length is increased, or increase the length of the floor in order to reduce. Let me write here why we are doing all these things. Why we are doing, sir, all these things in order to reduce. Can anyone tell me? Can anyone comment? In order to reduce, can anyone tell me? In order to reduce, anyone? No one will tell me. In order to reduce, anyone? Yes, very good. In order to reduce hydraulic gradient, in order to reduce head difference, in order to reduce hydraulic gradient, and hence the seepage force, and hence the upward seepage force. If upward seepage force which the water is exerting on the soil is reduced, then obviously soil erosion will not take place. And you will in soil mechanics, you will calculate the formula of seepage force. Okay, everything is there. I think you all must have studied also, I guess. So everything is there in effective stress chapter. Okay. Okay, then uplift pressure. You all know when water seeps through the soil, then it exerts an upward pressure. Okay, then it exerts an upward pressure equal to the hydraulic gradient which it possessed till now. Okay, and obviously I told you as water seeps, okay, as water seeps, hydraulic head goes on reducing because of friction, and obviously your uplift force will also start reducing. But in the starting, okay, but in the starting of the floor, you can see here in the starting of the floor, uplift pressure is highest. If anyone will ask you from where uplift is highest, you will say in the starting point here uplift is highest, but as soon as your water will start percolating or it will move ahead, then okay, then your what will happen, then your uplift pressure will reduce. You all have to remember this thing. Okay, no problem, sir. Okay, let's move ahead. And now study and the functions of all the components you all know till now. Then we have studied Blitzkrieg theory, which you all remember. We have studied Blitzkrieg theory. According to Blitzkrieg theory, he said moves from upstream end to downstream end, not by flowing, okay, not by flowing, but by creeping. Okay, according to Blake, water crept along the piles or along the floor and reached the downstream end. Okay, so the total length you all calculated. And what Lane told, okay, Blake, you are telling right, you are telling that water is creeping, but he added one point. What he added, I already told you, that this horizontal creep was less effective in counteracting the head. Okay, head loss in this horizontal creep is less, and head loss in this vertical creep is more. Okay, vertical creep is more effective in reducing the hydraulic head of the water, and it was in the ratio of 1:3:1. Okay, this can be asked, this one liner objective can be asked in ESE or anywhere. What it is, it is nothing but that the vertical creep is reducing three times head as that of horizontal creep. This question can be asked, you all should remember it. Okay, there should be no confusion regarding it. Now let's solve one question of this, then I will start Khosla theory. Okay, then I will start Khosla theory. So as you all can see here, piping failure, uplift pressure, everything is there. Okay, so he discussed two things. That if you want to prevent piping, then what we should do, length should be greater than, my dear sir, length should be greater than CH, and C was what? C was your Blake's coefficient. Okay, C was your Blake's coefficient. It should be greater than that. Okay, so and for uplift he told, or what we discussed, that the weight of the floor should be more. Weight of the floor should be such that it should be able to tackle the uplift pressure. Okay, uplift pressure should be less and weight of the floor should be more. If weight of the floor is more, then obviously your weir will not float. As you all know. Okay, so now let's solve a question based on both these criteria. And you all should remember that this L is your Blake's creep length. Okay, which should be as long as possible. Then it will be great. Okay, as you all know till now. So let's solve one question. My dear friends. Okay, let's solve one question. Or based on this, let me write on next page. Yes. So let's solve one question. I hope you all are ready. While designing a hydraulic structure, this question has been asked in previous year, so let's solve simply. While designing hydraulic structure, while designing wait one second. Yes, while designing a hydraulic structure, okay, piezometric head at the bottom of the floor, okay, we discussed yesterday that piezometric head was measured, one at the bottom of the floor and one was at the top of the floor. Piezometric head at the bottom of the floor is given in this question. Piezometric head at the bottom of the floor, taking datum as bottom of the floor, is how much is given as, weight is given as, wait 5 meter. Okay, is given as 5 meter. Yes, is given as 5 meter. Then piezometric head simply means hydraulic head. Okay, 5 meter. The specific gravity of the floor material, the specific gravity of floor material, I have simplified the question. The specific gravity of the floor material is 2.5. Floor material is nothing but concrete. You all know. Okay, is 2.5. Then obviously you will find the floor thickness. The floor thickness should be Now tell me. Now you all should comment and let us take a quick recap what we studied yesterday. You all can focus here. You all can see here that thickness of the floor should be h greater than h by g. We all discussed yesterday. I am taking the doubts, just wait. See here, thickness of the floor should be greater than h by g. G was nothing but your specific gravity. Like concrete floor is there, then obviously g will be density of concrete upon density of water, which is nothing but 2.4 to 2.5. Okay, in our question 2.5 is given. Okay, h is nothing but hydraulic gradient, or you can say piezometric head measured from bottom of the floor. Okay, measured from bottom of the floor. You all know this is your bottom, this is your bottom, and from here till top, h is your hydraulic gradient. Okay, no problem. No problem. This question has been asked, so I'm just telling you. And it can be in question, it can also give you hydraulic gradient from top of the floor. This is the top of the floor. Yes. Okay, no problem. It can also give you from top of the floor. So please be careful when to apply which formula. Okay, this formula you will apply when hydraulic gradient is given from top of the floor. Okay. Yes, 2 is absolutely correct answer. You all are right. No problem. But obviously wait. So yes, you all are right. T should be greater than h by g, and it should be greater than h is nothing but 5 meter. This is your gradient. Hydraulic head g is 2.5. So thickness should be greater than 2 meter. Okay, we can apply some factor of safety, and factor of safety is generally taken as 1.33. Let me tell you, factor of safety is taken as 4 by 3. Okay, so you will increase thickness. So obviously design thickness will be obviously more than 2 meter. Obviously you will provide more now, you have to be safe. So design thickness will be 4 by 3 into 2 meter, which is nothing but 8 by 3, or you can say 2.67 meter. Obviously you know, when balance has been made in 2 meter, then obviously you have to provide more than 2 meter in order to remain safe. Okay, yes. So design thickness will be even more. Okay, now I hope you all have understood this. Now let's move on to Khosla theory. Today we have to start that. So let's move on to Khosla theory. Okay, let me write down the heading. Khosla theory. Third theory, last sequence theory. This is absolutely correct. A lot of fluid mechanics is also applied here, but that we will not discuss in detail. You can cover that in FM only. Okay, we will discuss it. So Khosla was one of the great scientists. And with his fellow mates, he was a with his fellow mates. Okay, wait. Yes. So with the help of his fellow mates, he experimented a setup. He constructed a setup in his lab. Okay, he was a professor. So he constructed a setup in his lab, and he experimented a lot. On these weir and barrages, and he finally drew out some conclusions, those conclusions became very famous. Okay, those conclusions are very famous, and those are not like your Blix and Lanes. Okay, Blix and Lanes had assumed many things. Okay, it was much theoretical. So he has also experimented, and he has drawn out some conclusions. So firstly, let me tell you, he told that water is not creeping. Okay, water यहाँ पे जो है आपका पानी पानी आपका पायल के साथ चिपक के नहीं चल रहा. It is not creeping. He said this all is fake. According to Khosla, all these things are fake, and water will flow according to the concept of flow net. Okay, water will flow according to the concept of flow net. Darcy law, you all must have heard Darcy law. So let me tell you with the help of diagram that he told. Let me clear out the first point here. He told, suppose this is your weir floor. Suppose this is the weir floor. So water will not creep. Now forget about the creep which both of them told. Now actual thing. Now what happens in actual? Suppose this is a barrage, this is a gate. Okay, water is filled here. Now water will move according to the flow net. You all must have heard about the concept of flow net. Okay, in which phi and psi is there. You all know phi. I think you all must be knowing. Wait, let me draw. Then you will understand more. These are your streamlines. You all know these are your streamlines like this. And kindly do not panic if you all do not know this. These all topics are of soil mechanics. Okay, you all can cover these topics in soil. In soil, one chapter is there which is known as seepage. Okay, there you can study all these things. You will get full depth there. Okay. So because obviously you all know that from soil water can seep through, water can pass through. So what should be the theory which you should follow? Are you are engineer? You should know how much water has passed through it. Okay, seepage. You have to calculate the seepage. You must have heard formula K HF NF upon ND that is in soil. Okay, so don't let's not dig into that now. So these are your streamlines and these are your potential lines. These lines are your equipotential lines. You all must have heard about it, I guess. So these are your equipotential lines in which head is same, Let me draw some more so that you are more clear. And these are your equipotential. This is your first equipotential line. This is second, third, fourth, fifth, sixth, and seventh. You can say like this last one. So it is like that. It is like that. And for detail, you can cover this topic in soil. So you all know this is your flow net. This entire thing is your flow net. And in flow net, two types of lines are there. You all know. One is your streamlines, my dear friend. One is a streamline between which actual water flows. Okay, between these streamlines, this is your first streamline, second one, third line. Obviously, water will flow in between this line, like this, from one point to another. Not, it will not creep along the length of the floor. He has told that water will flow according to Darcy law. It will follow the concept of flow net. Okay, in a homogeneous soil, you all know. And then flow net also consists of, and then your flow net also consists of equipotential line. Equipotential line, nothing, these lines, along these lines head is same, that's why equipotential we are calling it. Suppose this is your water. If your water is stored here 5 meter, suppose hydraulic gradient here is 5 meter, then obviously on this line head will be 5 meter. When it will move from 5 to here, okay, when it will move like, wait, when it will move, then obviously in between it will move, then obviously head will reduce. So now suppose by reaching here, head reduced, and it became 4.2. Then also, okay, it is like that. On further moving, between streamlines, water further moves here. Okay, in between streamlines, head will further reduce. So here 0.8 has been reduced, so again 0.8 will be reduced. Now it will become 3.4. It goes on like this, and it will, at the end it will reach 0, but head will go on reducing. But on this line, on this entire line, my dear friends, head will be equal. That's why we are calling it as equipotential line, which will be equal to 4.2. On this line, head will be equal to 5. On this line, head will be equal to 3.4. It's like that. Okay, you all must know. So these theories, from where this came, you all should study this in fluid kinematics, in FM and soil. We are not here to discuss that. So I guess we are here to discuss the conclusions of Khosla. Okay, what he told, we are here to discuss the conclusions of Khosla. We will discuss that in detail. Okay, we will discuss that in detail. So first point, okay, first point. Then, if in soil mechanics, if you know, in soil mechanics, wait, let me write down one point. Okay, in soil mechanics, you all know this has been established both from both point of view, theoretically also and experimentally also. If Darcy law is good, if Darcy law holds, and what is Darcy law? Anyone know? If Darcy law holds, okay, then then steady seepage through homogeneous soil, then steady seepage. Steady means something which remains constant with respect to time. Okay, these heads will not change with respect to time, or discharge will not change with respect to time. We are referring that as steady, something which is not changing with respect to time. Your potential, your flow, everything. Then if Darcy law holds good. Okay, good is missing here. If Darcy law holds good, then steady seepage in homogeneous isotropic soil is represented by Laplace equation. Is represented by Laplace equation. Okay, is represented by Laplace equation, which is given as del 2 phi upon del x square plus del 2 phi upon del y square. I hope you all have read this. this is nothing but your Laplace equation. So Khosla found that general Laplace equation, which is okay, which has been used. Achha, let me tell you one thing. Soil mechanics, entire soil mechanics has been developed in recent 70 to 80 years, from 1925 you all can say. So all the seepage theories or every work, everyone on soil mechanics, okay, how seepage of water takes place through soil, what is settlement, consolidation, everything is developed later. So Khosla is one of the latest scientists, and he used the seepage theory of which you will study in soil. Okay, what is phi? Phi is nothing but your equipotential. See, okay, let me tell you simple. This is your phi and this is your psi. How many of you heard about this phi and psi? This psi is related to the discharge because psi is your streamline related to discharge, and phi is the difference of head. Remember, my dear friends, if head is more, if difference of head is more, then obviously water will be very speedy. If this gap is 5 and 4.2, then obviously water will be slow, somewhat. See, and if head difference is 5 and here it is say 1 meter, then obviously 4 meter gap is there, and if difference is more, okay, then obviously water will flow fast. Okay, water will flow fast, or you can say more the difference, more is the speed. More the difference, the water will try to balance the head on both sides. Okay, why water is moving from here to here? Because it wants to balance. It is a rule of the nature. It is a rule of the nature. Air flows from high pressure area to low pressure area. Pressure has to be balanced. It is like that only. Okay. So he said this is your formula. Phi is nothing but equal to KH. K is permeability of soil. H is your hydraulic gradient. Okay, H is your hydraulic gradient. You all know. Phi is your potential. Phi is your potential function. Phi is your potential function, and psi is your stream function. Psi is your stream function, and you will study about all these functions in detail. We are not going to discuss what is phi, what is psi, what is the concept of flow net. You just remember there is flow net. Okay, net, as you all can see, net is there, and this net consists of two lines, two set of lines which are perpendicular to each other, which are orthogonal to each other. Okay, you must remember this one. H is obviously you all know, seepage head at any point. Okay, which is going on reducing, which is highest at the upstream point and lowest at the downstream point. H is nothing but seepage head, and K is your permeability. So Khosla told, so according to Khosla, yes, according to Khosla, everything is in accordance with seepage theory. Everything is in accordance with seepage theory. Yes. You all can study this in your soil mechanics. Sushma has, let me take one doubt. Two questions has been asked. Sushma has been asking that, sir, in canal designing we are finding final regime dimensions. Yes. No, sir. Yes. Absolutely correct. Sushma, in LACE design, the design, okay, you must have solved simultaneously the equation, width, depth. Okay, yes. That was the final regime dimensions, obviously. When everything becomes constant, discharge, silt, grade, everything becomes constant. Then Malaya is asking, sir, why crest level is lower than that of beer? Malaya, listen very carefully. Because because the silt, see, comments are now visible. No problem. What I was telling, yes. See here in this crest level you are asking, or you are asking crest level here? You are asking here crest level. Or now comment will come after some time. YouTube is like too much of lag is there. So let me tell you both points so you can understand anything. See this here, a lot of silt is there. So we depress the floor. So that more amount of silt is getting scoured towards the downstream side. This is one aspect. And this crest, okay, this crest, we know if we will make fully the crest, okay, if fully we will make weir wall, then obviously we will not get a full control over it. So what we do, we construct partially, we construct something as raised floor and something we control by gates. Okay, we have to control the flow partially, because why we are constructing gates above? Because gates are in our control. Okay, so something has to be there which should be in our control. Obviously control has to be there when water is rising. When water is rising, suppose flood is there, so obviously water will rise and gate will, are you getting my point? Gate will stop that flood water, and if you open that flood water, then obviously water will flow from upstream to downstream and upstream to downstream, and it can cause scouring and everything here, but you have already protected it with block protection. Okay, so these things are there. So crest is somewhat lower as compared to your flood level. Okay, see, river also has many levels. One is your maximum normal pool level, then it is your maximum pool level. For maximum pool level, okay, for maximum level we have gates, or we have gates. We can control when flood water is extra, we can store it, but when water is, we are unable to store the surcharge water, then we have to release it. Okay, that can be controlled by gate. Obviously you all know that you cannot control the extra water with the help of weir. Yes, and these gates can be, this gate level can be changed. Okay, it can go down, it can go up, it is like that, it is sluice gate. Okay, so let's move on here. I hope doubt is clear. I hope doubt is clear. Now let's understand the conclusion. So according to Khosla, no creeping is there. Now let's draw conclusions. Okay, according to Khosla, no creep is there, no creep is there, and water is flowing simply the following the concept of seepage theory, which we will study from, which is study in soil mechanics. Okay, which is study in soil mechanics. Now he performed many experiments. He performed many experiments and drew out some conclusions. Let us understand that those conclusions. What he did, what he did. Okay, listen. So he, for a quite long time, wait, let me draw the diagram. For a quite long time, for long time, you know, Blake's theory was popular for long time, but at the end, after proper research and everything, Khosla theory was widely accepted later. But okay, after long time of, after long time, Khosla's theory was accepted. Before that, Blake's theory was very popular. Okay, Blake's theory was very popular. So why Blake's theory failed? What Khosla told, failed the Blake theory, failed, was the reason for the failure of the Blake theory. So what he told, let us discuss that. What he told, let us discuss everything. So he experimented a lot. He experimented a lot. Suppose this is your weir. Suppose, friend, this is your weir. Okay, this is your weir, and water is stored here. Water is stored here. Or, and now you all know that water will not start creeping. Water will not start creeping along the piles or along the length of the floor, but it will move it like this. It will move like this. Okay, it will move like this, okay, following the concept of seepage, like this. Okay, it will move like this, it is like that. Okay, following the concept of flow net. I hope you all can understand. So now he drew out some conclusions. Let me write down conclusion one by one here so that you can remember. These all were the investigations made by Khosla and all his PhD fellow mates. Okay, all his PhD fellow mates. So the first point which came in light after the experiment of, after the experiment, so in this experiment he took permeable foundation, he took soil here below soil and constructed a weir above it. Okay, weir, and obviously he observed the seepage for long time. He carried out experiments and observed the seepage which is taking place in the soil for long time, and he drew out, let me tell you, he drew out four conclusions. Let me tell you by like this only, then I will write it. See, he told that the outer faces, see, this is your outer face, this is your outer face of pile, and this is your inner face of the pile. No problem. Yes, sir, I have understood this. This is your outer face, and this is your inner face. So he told, Khosla told that outer face of the pile is more effective in reducing the head as compared to inner face. Okay, why, sir? Because obviously water will touch the outer face only. When water will touch the outer face, then obviously what will happen? Then obviously friction will be there, and obviously head will get lost. And here also outer face is more effective. Why not? Why inner face is not effective? Because it is inside and water is not touching that. But according to Blake, my dear friends, Blake told that water will turn from here and it will creep like this, but it is not the case. It is not the case. Okay, in actual, he found, okay, he found that outer face are more effective in contracting the head or in reducing the head as compared to inner face. This you can easily understand because you can see here. Okay, you can see in this diagram. Okay, and you all know water will flow like this according to the concept of flow net. No problem. Yes. Now the next point he told is of intermediate pile. This intermediate pile you all can see. He told, listen very carefully, if this intermediate pile is smaller than, okay, is smaller in length than the outer piles. Are this is your outer pile, this is your outer pile, this is intermediate pile, the inner one. If this pile is lower, if this pile is less in length, is shorter in length than the outer piles, then obviously it is not contributing anything in reducing the head. It is not contracting any head of the water. Okay, then now what you should do, now if you will increase the length, now if you will increase the length of the pile like this, if you increase the length of the pile like this, then what will happen? Can anyone tell me? Then what will happen? Then your water has to move like this, then your water has to move like this, it will go here. And now tell me the path of the seepage, now tell me the path of the seepage has increased or decreased? Tell me, has it increased or decreased? Sir, it has increased. And obviously when length will increase, hydraulic gradient, I have already discussed these things with you yesterday. If length will increase, hydraulic gradient will decrease, and we will become safe. We will become safe. Okay, force will become less when it is coming out. No problem. So you all can appreciate the fact that when the length of the intermediate pile is greater than the outer piles, then only your intermediate pile is effective in reducing the head. This is the conclusion. Otherwise when it was short, no, it was not effective, it was ineffective, you all can say. It was not effective in reducing the head. I hope you have understood. Next thing which he observed in the experiment, when he was conducting this experiment, okay, when he and his team was conducting an experiment, next thing which he concluded was, he saw that whatever piping was occurring, piping you all remember, na, tunnel which was made from downstream to upstream side. He observed that soil erosion started from downstream, and slowly and slowly and slowly and slowly, that we have already discussed yesterday, slowly and slowly and slowly, your pipe or tunnel gets starting completed towards the upstream side. And when this pipe is completed, then obviously water will rush in, water will immediately rush in. Okay, are you getting a point? So he observed that, what he observed, I was saying, yes, that piping started from downstream end and erosion started taking place from downstream end, and this tunnel or pipe, okay, gradually progressed from downstream end to upstream end. This was your third observation. And the last observation was that the if downstream pile is not there, can you see all? This is your down. Let me write down so that you all can connect easily. This pile is known as your downstream pile. This pile is known as your intermediate pile. Okay, and this pile is known as your which one? Upstream pile. Okay. Okay, if downstream pile is not there, then you cannot reduce the upward seepage force. If downstream pile is not there, then nothing will happen. Obviously erosion will take place. Downstream pile had to be there anyhow. That was your fourth conclusion. Why? It is supported by some facts you will see here. So let me write down the first point, that the outer face, let me write down the first point. Let me write down the outer face of end sheet piles. The outer face, remember very carefully all these theories. These are very important points from ESE theory point of view. Okay, in ES everything is asked. The outer face of end sheet piles, my dear friend, were found to be much more effective than what I already told you. Were found to be much more effective. Okay, were found to be much more effective than inner ones. I already told you, then inner ones, then this inner faces, and also the horizontal length of the floor, because this horizontal length of the floor is also not contributing. Can you see? Water is not creeping along the horizontal length of the floor, and horizontal width or length, you can say whatever you want, and horizontal length of the floor. Then what is your next conclusion? Simple, that if this intermediate pile is shorter in length, let me write down, if intermediate piles, the piles which are in between, if intermediate piles are shorter in length, if intermediate piles are shorter in length, okay, or smaller in length, you can say, than the outer ones, then the outer ones, then the outer ones were found to be ineffective, were found to be ineffective in counteracting the head, okay, were found to be ineffective. Then comes your third point, that he told piping or undermining, okay, undermining or piping, whatever you can say, whatever seepage failure was there, undermining or piping of floors started from which end? Tell me, started from which end? Started from tail end or downstream side. Started from downstream side, or you can say tail end. And the last point was that downstream pile was extremely necessary, otherwise nothing will happen. Okay, it was essential, to have a deep vertical cutoff, to have a deep vertical cutoff, to have a deep vertical cutoff, to have a deep vertical cutoff at the which end? At which end? At at which end? At the downstream end. Okay, at which end? At the downstream end. Okay, at the downstream end of the floor to prevent piping. To prevent piping or undermining. Undermining is nothing, simply erosion of your soil beneath the floor. Under means below the floor. Mining means you are eroding it. You are eroding the soil. Okay, these were the four formulas which are drawn by Khosla. Now let us discuss the formula which was given by. Okay, so now till now no doubt is there. Okay, next let's proceed. Okay, now I hope this is clear. I hope this is clear. Now he gave formula for exit gradient. Okay, he gave independent variables. He gave the formula for exit gradient. First, let me discuss the formula for exit gradient because that is very important. Okay, that is very important. So one formula, should we discuss it on next page? Yes. Let us discuss it on next page. Okay. Let me write down. Let me write down. Okay, so exit gradient according to Foster. Let me write down here. Exit gradient according to Foster. So he gave formula for exit gradient. Acha, first tell me, you all remember hydraulic gradient? Let me tell you one thing, otherwise you will be a little bit confused because you have, I think you all don't have any idea about soil mechanics because you will study later. In CPS, three conditions are there. Let me tell you very clearly so you will connect easily. Okay, no problem. See, weir is here. This is your weir. This is your floor of the weir. Here soil is there. Okay, here soil is there. Okay, now listen very carefully. When water comes out, water tries to comes out. The gradient, the hydraulic gradient here, the hydraulic gradient here is known as exit gradient because water is coming out na, water is coming out from here in upward direction. Yes, so the pressure difference or the head difference due to which water is coming out is known as exit gradient. If this exit gradient was not here, if this difference in the head is not here, then obviously water will not come out. If the head is same, then why water will flow? Water flows from high head to low head. You should remember. You should know the fact. Okay, dear sir, I have understood this. Now listen very carefully. You should appreciate these three facts that if that if this exit gradient or if gradient simply hydraulic gradient, you all can appreciate if this exit gradient or simply hydraulic gradient is less than one critical value is there. If it is less than that value, then there is no problem, then we are safe, and no undermining will take place, and we will say that the weight of the soil is more and upward seepage force is less. We will say weight of the soil is more and upward seepage force is less. That's why your soil is not going up, That's why your soil is not in quicksand condition. Your soil is not boiling off. Okay, we will say that we are safe, no undermining will take place. And if unfortunately this exit gradient, or you can say head difference, or if length, you see this formula for exit gradient is nothing. Exit gradient is simply h by l. Simple. If head increases and length decreases, you will be in problem. You will be in problem. Okay, because if head difference is more and length has been reduced, and that head difference has been changed in very small length, then obviously your exit gradient or simply hydraulic gradient will be very high, and obviously then force will also be high. You all can appreciate the fact, if the difference in water level is more, then water will rush very fast. You should remember this. Then gradient will be very high, and obviously it will apply more force. So if somehow if exit gradient increases and becomes equal to critical value, then obviously what will happen, your quicksand condition will occur. I think quicksand condition you all must not be familiar. I am just telling you so that you have just idea. And what happens in quicksand condition? Nothing. This weight of the soil downwards. See, suppose this is a soil particle. It is having some weight downwards, net effective weight downwards. Okay, and one force is being applied upwards. Who is applying this force? Water which is coming upward. Water which is coming upward is applying upward seepage force. Upward seepage force. Okay, water is coming upwards, so by seeping, so it will apply upward seepage force. If this upward seepage force is less, then first condition is there. If this upward seepage force is equal to the weight of the net weight of the particle, then second condition. And what will be the third condition? Extremely disastrous condition, my dear sir, when your upward seepage force will be greater, or you can say, sir, exit gradient is so much that we are not able to stop the soil, and you are seeing that soil is coming out like this. Soil will pop up out of the soil will come out by jumping from this place. Okay, it will jump here and start eroding. Erosion will start happening. Yesterday I have discussed this. You all know, na? You all know. Yesterday we have discussed this. Okay, and in this case, this is known as a boiling condition. You will see that soil is jumping. Okay, you will see soil is jumping. Boiling condition. This is your boiling condition. We don't want second and third condition to happen. We want to be safe. We want your exit gradient to be less than critical value. We want exit gradient to be less than critical value. What Blix told yesterday, that exit gradient is h by l, and this critical value is somewhat related to somewhat like this, which depends on soil. I hope if you have studied soil, you must have heard the formula of critical gradient, which is nothing but g minus 1 upon 1 plus e. How many of you have heard this formula? I hope you have studied this. I hope. Anyone? So he told, Khosla told the formula for exit gradient. What was the formula? He told it. Okay. He told the formula after experiments. What was that formula? Exit gradient is equal to h by d. Wait, let me write it here so that we can solve question also. Yes, exit gradient is equal to h by d 1 by, this formula is very important. This formula is very important, pi under root lambda. This is your formula. This is your formula, my dear friends. Now let me write down the full form of each thing. First lambda also. First let me write complete lambda also. Lambda is 1 plus under root. Questions has come from this formula. This is very important formula when it comes to your divergent headwork chapter. In divergent headworks, this formula is most important. Till now, whatever concepts you have developed, those are not that important as compared to this formula, because questions come directly from this formula only, that I am telling you. And alpha is your b by d. Alpha is your b by d. Now you will ask, sir, what is b, what is d? Tell me everything. Wait, I am telling you. See here. This is your length of the floor. This is your barrage. This is your downstream pile. Okay, three things are there. And water is filled here. Water is filled here. Suppose the head of the water is H. Suppose the head of the water is H. This is the head of the water. Okay. And this length of the floor. Okay. This is your B. What is B? B is nothing, my dear sir, but length of the floor. And this is your D. D is the depth of the downstream pile. Listen very carefully. Let me write, otherwise you will forget. D is depth of downstream pile. Yes sir, clear. B is, you can see D here, na? B also, B is nothing but length of the impervious floor. Okay. He has developed one theory of independent variable. From there he has derived these formulas. You should not focus on all those things. Okay. You should focus here on this formula only. Okay, so first you will, in question you will be given H, you will be given B, you will be given D, and exit gradient will be asked. Okay, exit gradient will be asked, and we will see how questions is solved. Okay, don't worry. What I was telling. Yes, so first you will find alpha. Step 1, find alpha. Alpha is nothing but UID. Then in the second step, put this alpha here. Put this alpha here. Okay, you can see, and find lambda. Okay, and then you will put this lambda here. Then you will put this lambda here, my dear friends, and you will put lambda. Pi you all know. 1 you all know. D is nothing but your depth of downstream pile. H is the head of water which is stored behind the barrage or weir. H is the head of the water which is stored behind the barrage or river. You all can, okay, you all can find and put the values. Okay, yes, so this is your exit gradient, very important formula. Now listen very carefully. Now listen very carefully. For safety, for safety, okay, for safety point of view, your exit gradient should be as less as possible. Are you getting it? Are you getting it? Your exit gradient should be as less as possible in order to prevent undermining. In order to prevent undermining. So the you will write like this. You will write like this, that you will use some factor of safety. You will use some factor of safety. You will use some factor of safety and reduce it. And let me say right like this, that the hydraulic gradient which is actually existing, suppose actually the hydraulic gradient which is existing, say it is I, it should be even less than, it should be obviously less than exit gradient, but exit gradient should be divided by a lot of factor of safety, so that your definitely your I is less than this value. Okay, let us take one example so that you will understand clearly. Suppose your exit gradient, okay, your exit gradient is coming out as G. Wait, let us solve with this by example so that you will understand. Let us take one example. Okay, so let's take one example, you will understand this very clearly. So solve all that question which has also been asked in exam. Solve this question. Okay, so solve this question. Solve this question which has come in exam. Wait, let me write. Okay, in this question it is given. In this question it is given that the head of the water, the head of the water, the head of the water is given as, this is the question which has been asked in previous year. Okay, in previous year this question has been asked. Very easy question this is. Let me draw the diagram here only. This is the head of the water which is given as 5 meter here. Okay, which is given as 5 meter, my dear friends. Okay, no problem. Yes sir. Then the length of the floor is given as, my dear students, length of the floor is given as, let me write down, length of the floor is given as 10 meter, my dear friends, 10 meter, and the length of the downstream pile is given as, my dear friends, 4 meter. Okay, this is the diagram which they have drawn in the question. This is a previous year question, dear friends. Let me write down 4 options here. Okay, also check the safety, also check, wait, also check the safety, also check the safety of weir with respect to undermining. Also check the safety of weir with respect to undermining if, with respect to undermining, if critical hydraulic gradient is given as, if critical hydraulic gradient, critical means if you will reach this critical gradient value, then everything will collapse. If critical hydraulic gradient is given as 0.5, is given as 0.5, we will check the safety also. So first you will find exit gradient, first you will find exit gradient, and you will pray to God, and you will pray to God that God, exit gradient should be less than the critical value. Exit gradient should be less than the critical value. Okay, yes. This we have already discussed here. This we have already discussed here. I already told you that the exit gradient value should be less than critical value if you want your soil not to undermine or not to get eroded here at the downstream end, so that no undermining takes place. Okay, so this is for safety, this is for safety point of view. Okay, and for design you can write like this, and for design you can write like this, that you will reduce critical value also. Why you will take the risk? Why you will take the risk? You will reduce that extreme value to somewhat lower one by dividing it by factor of safety. Okay, it is very simple. For design point of view, exit gradient should be too much less than critical value. Okay, so solve here. Let me write down the exam options also. First option is, everyone will solve this because this is very important question, and everyone will write like answer A, B, C, D like this. Comment like this, everyone. Okay. So this is option A 1 in 6. Option B is there 1 in 5. Option C is there, my dear friends, 1 in 3.4. And option D is there, my dear friends, 1 in 2.5. Now let us solve and check the safety also. Okay. Yes, Sagar, you are right. Sagar, comment the answer here in this format A, B, C, D. Which is the right answer, A, B, or C, or D? Sagar, can you tell? Everyone, please solve. Wait, let me show the previous slide so that you can see the formula. So that you can see the formula. Yes, very good. See. And is it safe? Is it safe or not? See, first find alpha, which is nothing but b by d, then find lambda and put the value of lambda here and find g. I am giving you 1 minute. Everyone should solve. Try this. First find alpha, b by d. What is b given? B is given as 10. Let me write down. B is given as 10. B is given as 4. D is given as 4. And head is given as 5. Okay. Head is given as 5 meter. So first you solve b by d. Tell me. Everyone kindly solve. It's a humble request. This is very important question. Yes, everyone is correct. Good. Very good, everyone. Now let's solve. Everyone must have found alpha, which is b by d. Alpha is 2.5. Yes, very good, Adesh. Then we will find lambda. Then we will find lambda. Lambda is 1 plus under root 1 plus alpha square by 2. Yes, very good. It is coming safe. It is safe. You are right. Lambda will come out as 1.8463. Then G will come out as h by d 1 by pi under root lambda. Very good everyone, very good. H is given as 5, we will put 5 here, we will write 4 here, 1, 5, and you all are right. When you will solve this, G is coming out as 0.29, or you can say 1 in 3.4. This value is equal to this only, very simple. This 1 upon 3.4 is nothing but 0.29, everyone knows this. Now we will see, now we will see. Now let us also find safety. We will write your beer is safe. Beer is safe when it comes to undermining. Beer is safe from undermining. Beer is safe from undermining, my dear friends. Why? Because exit gradient is less than critical value. Sir, exit gradient is 0.29 only and critical gradient is 0.5. Okay? Yes, you all are right. You all are absolutely right, dear friends. It is safe. Yes, sir. I have understood now. Acha, can you find factor of safety here? Can you find factor of safety here? How much factor of safety is there? Higher value upon lower value. Simply. This will be your factor of safety. It is not asked, but I am just telling you how much safe you are. If critical value is 0.5 and actual value is 0.25, then you are 2 times safe, na? Then you are 2 times safe. It is like that only. It is like that. It is simple. Okay. Now let's move ahead. Everyone comment, please. Everyone comment. Sir, I have understood till here. Comment. Now one more point is there. First comment everyone. First comment, then I will proceed because this is very important. Only 3 to 4 students out of many have answered only. Okay, now exit gradient. Yes, okay. See here. In this, now focus clearly. Focus here clearly. See, in this exit gradient formula, D is in the denominator. Can you see all? See, D is in the denominator. You all remember, you all know that the value of G should be as low as possible. Okay, should be as low as possible. So, yes, very good. So, how the value of G can reduce? Can you all tell me? Can anyone tell me? D has to be increased. Depth of the, see here, depth of the downstream pile has to be increased. Listen very carefully. Listen. This has to be increased. This can be one objective which can be asked in your exam. Sir, D, depth of the downstream pile, if it will increase, then obviously your exit rate will increase. Okay, so I am writing here. If depth of downstream pile is not here, carefully see here. If suppose you are out of your mind and you didn't provide it, you didn't provide this D. Okay, so what will happen? You will write here if D is equal to 0. If you will not provide downstream pile, na, see here. The more you will embed it, the more you will embed the pile, the more you will embed the pile here. Okay, the more will be the depth, the more will be the depth, more the water has to travel more, if water will travel more, okay, if water will travel more, then obviously what will happen? Force will be reduced. Okay, so this depth is very important, and I already told you yesterday that in reducing the seepage pressure at the downstream end, downstream pile is more effective. So D has to be maximized. But if suppose you are not providing, if you are not providing any D, what will happen? Can anyone tell me? Put D as 0 here. If you are not providing D, let's check what things can happen. Put D as 0. Tell me what will be the value of exit gradient. Tell me what will my exit gradient become. Sir, in such a case, exit gradient will tend to infinite, will become infinity, and this is disastrous case. No matter what, sir, you do anything, you will not be able to control your what, you will not be able to control, you will not be able to control what? Can anyone tell me? You will not be able to control undermining. Undermining will happen for sure. Undermining or piping failure will definitely happen. Soil will start coming out from here no matter what you do, and tunnel will start forming, Okay, that's why we want this exit gradient to be less, na? So obviously we have to provide downstream pile. We have to provide downstream pile at any cost. And this was, my dear friends, the formula, the fourth point. This was, my dear friends, the fourth point of Khosla conclusion. See, read. He told it was essential to have a deep vertical cutoff. Okay, deep vertical cutoff means downstream pile. He has to have deep vertical cutoff. And why he is focusing on deep? Why he is writing deep here? Because the more the depth of the downstream pile, the lesser will be the exit gradient. The lesser will be the exit gradient. See here. Okay, at the downstream end to prevent undermining. So this was very essential, because if you will see here, if you are not providing D, then obviously G is infinite and you will not be able to control undermining. Remember this formula. This line can become your objective. Okay, so it should be very deep. Your cutoff should be very deep, so that this D should be very high, so that exit gradient is less. And if exit gradient is less, then obviously you will be safe. Okay. Khosla theory is almost finished. One more point is done. Last point is also there. Then this chapter will finish and we will start canal regulatory works. Okay. Let's move on to last point, so that everything you all understand and no problem is there. Whenever you will solve GATE, ESE, every question will solve. Last point. Hope you have understood everything, and all these things are experimental, which are derived by Mr. Khosla. Okay. So last observation, he was great professor. And he did a lot of work when it comes to your weir and barrages. So one more thing he done, he performed one more thing. One theory he gave also, Khosla's method of independent variable. We are not going deep into this, okay, because this is not that important. Otherwise, this theory only will take, this method of independent variable will only take 3 to 4 hours. Very huge theory it is. Okay, but we are only interested in the major points which can come in exam, because in exam, in GATE, some points regarding this has come. Okay, so according to this, suppose your let me write down here, dear friends. Suppose this is your floor, this is your weir. Till now you have understood this very clearly. Now you are fully aware of all these things. Now no problem is there. This is your weir, this is your floor, this is your downstream pile, and suppose upstream pile is also there. So according to this theory, my dear friends, according to this method, not theory, according to this method which he developed after all the conclusions which he developed and published his paper, after this theory he developed a method. So this method of independent variables, what he did, he he divided this entire weir or barrage system, he divided it into several small parts, into several small parts, and gave the formula of phi at each point. Gave the formula of phi. Phi is nothing but a potential head. See, phi, I think you must have forgotten. See, this is your phi, potential function. Okay, potential function. Obviously, potential function is a function of head. More the head, so obviously potential will more. If the head difference is more between 2 lines, then obviously potential function, or you can say water going from high head to low head, is also more. Okay, yes sir. Yes sir. See here. So he divided this weir into small sections. Okay, or you can say in this method, a composite weir or composite barrage is split up into number of simple standard forms. Okay, so how he divided it? Let me write down here how he divided. So he converted this into this. He converted this setup into like this. Wait, let me draw into two forms. Like this. Split it from the mid. Okay. Wait, let me draw first. Then I will explain. This is very important. From GATE point of view. Suppose water is filled here. Okay, water is filled here. No problem. Water is filled here. No problem. Yes, sir. Very simple. I can understand easily. Yes, sir. Now tell me. And remember, these two are not different. These two are same. Only this has been splitted into two parts. Okay. This is this plus this. This entire setup of that VR is this plus this. He has split it into two simple standard forms only, nothing else. Now, see here. Suppose this is your upstream point. Suppose this is your upstream point. Let me write down here only. Let me write down here only. Let me write down. This is your point A. This is your point B. This is your point C. This is your point D, E, and F is there. Okay. We have already discussed, my dear friends. We have already discussed. Listen very carefully. We have already discussed that whenever water will move, my dear sir, whenever water will move. Okay. Suppose it is moving like this. Suppose, obviously we all know it does not move like this, it does not creep. But suppose if if it moves like this, then obviously when water will proceed, when water will move gradually, then obviously head will reduce. You all appreciate this fact that head will definitely reduce, my dear sir. Yes, obviously head will definitely reduce. So I can say if head is 100% here, my dear sir, then at point B it will be somewhat less, 80%, only 80% of the energy of the water is left now. And at C, less energy will be there. Suppose at C 70 is there. Let me write down. At A, suppose 100% energy is there. Then obviously, my dear sir, at B 80% energy will be there. At C, which is further downstream, I will say at C, suppose 70% energy is there. Listen very carefully. Listen. Then at D, obviously somewhat less energy. Suppose this is very long and too much of energy has been lost. So now I will say 30% of hydraulic head or energy is reduced, is remaining now. And at D, and at D, EE, D has already happened. At E, now even less energy will be there. And obviously when water will reach F, entire energy of the water will be finished. Entire energy of the water will be finished. I can say like this. Why? Because if energy is left at this point F, then what will happen? It will explode out. It will explode out and erode all the soil, and it will start the formation of pipe. Will start the formation of pipe or undermining. You all can understand the fact. That's why we want at this point F, when water is trying to come out, at that point the head should be zero. At that point the head should be zero. Yes, sir. This is very much clear. Now, sir, I have understood. That means you are trying to say, my dear sir, suppose head of the water is 5, then it will reduce to 4, then it will reduce to 3, 2, 1, and then 0. It will be like that. Yes, sir. Yes, I am telling the same thing. I am telling you the same thing. And that head, we are not writing directly the head, we are writing 5. We are not directly writing the head, we are writing the phi. Okay, and phi is nothing but the remaining head. Okay, head in percentage. What is phi? It is simple. Let me tell you what is phi. Phi is nothing. Suppose B point is there. Okay, at B 4-meter head is left. At B only 4-meter energy is left. Okay, only 4-meter energy is left. And at A, when it started, when the water started its journey from A point, then the head was 5-meter, then the energy was 5-meter. So how much energy is now remaining in terms of percentage? When you will say how much amount of energy is remaining in terms of percentage, you will say, my dear sir, 80% of energy is remaining now. Suppose at any point F, no energy is remaining, so I will write 0-meter. What was the total energy? 5-meter. Are you getting it? From the example I am telling you, 5-meter energy was remaining there. Okay, so I will write 0%. So phi is nothing but phi is nothing but percentage of head remaining. Phi is nothing but, you can write here simply. Let me write down here. Let me write down here, or where should I write? Yes, let me write down here. Phi is percentage. Wait, let me write down very clearly. Percentage of total head. Percentage of total head remaining at any point. Percentage of total head remaining at any point. Okay. The less the value of phi, head remaining at any point. The less the value of phi, less will be the problem at extreme point. Okay, sir. Now what he has told, tell me the formula and conclusions. Sir, directly come to the point. What he has told before going, before leaving this world, what he has told. See here. Now see the points very clearly. See the point. This is your A. See, this is your A. Same in the similar fashion, points are allotted here. I will write here only. This is A. Yes, sir. This is B. This is C. And since you have splitted this in between, okay, this has been converted into two parts. This is your upstream file. Let me write down. This is your upstream file. and this is your downstream pile. Composite section has been splitted into two parts. Okay, this is your D, this is your D, this is your E, this is your F. Okay, so what formula he gave? Well, listen very carefully, otherwise everything will mix. He told, listen very carefully, this C point and D point. Can you all see C and D? C in actual, before this is C, this is D. The sum of value of phi. Okay, phi. You all know some C, phi will be there, D will be there. Okay, so you all can see that the sum of phi value at C and D is equal to 100. See here, C and D sum equal to 100. He observed this and he gave formula. Okay, C and D are 100. Then you all can also appreciate that the sum of phi at B and E, that the sum of value of phi at B and E is also equal to 100. 80 and 20 is also equal to 100. Observe this. Okay, both are equal to 100 when it comes to the sum. Okay, yes sir, clear. So let me write down here what he told. He told first let me write down the formula for phi at D which he gave. Phi at D, if you want to calculate, he gave one formula, 1 upon pi cos inverse lambda minus 2 upon lambda. Lambda is same. Okay, and phi at E, if you want to find out, this is D, this is E, and in actual this is D, this is E. Okay, and phi at E is equal to 1 by pi cos inverse lambda minus 1 upon lambda. Okay dear friends. Okay, yes sir, I am fully aware of this. Now I will, don't forget this. Okay, so this is your formula for phi at D and phi at E. This will come out obviously in percentage, and let me write down what lambda is so that you all are not confused. Lambda is same. Arey bhai, lambda is same thing. 1 plus under root 1 plus alpha square by 2, and alpha is nothing but B by D. This is your D. You all know na? This is your D and this is your D. This is your D and this is your B. Same thing, nothing else. Okay, nothing else. So what Khosla did, he splitted your main wear into two sections and gave formula differently. This is your B. Okay, same. He split it into sections which are of standard form, so that we are able to solve it simply. Okay, so that simplification is done. So this is your B. Okay, so one time he only applied downstream pile and one time he only applied upstream pile, and then he did the superposition. And obviously when you will combine this result and this result, then obviously this will happen. Okay, so no problem. So he gave the formula. Then now tell me, what will is the value of phi at C? Can anyone tell me? Comment down. I have already told you. You will find value of phi D from here. Okay, like this, simple. And the value of C will be nothing but 100 minus the value of phi, or the potential function which you have already find out at D. Okay, yes, clear? Yes sir. And since you have already found the value of E, found out the value of E, the value of phi at B will be 100 minus, my dear sir, value of phi at B will be, my dear sir, 100 minus phi E. And because B and E sum is 100 and C and D sum is 100, you all can see C and D, this is your C and this is your D, both will sum up to 100. Okay, and this B and E will sum up to 100. This is the formula which you all should remember. Okay, and after this we will solve one question of GATE. Yes, absolutely correct. You are Sagar, you are absolutely correct. Now we will solve one question of GATE which has come from this with this method of independent variable. Are you ready to solve the question? Let's take one question. Wait. We will solve the question which has exactly come in GATE. No worries, so that you all become champion from now on. You all are champions from now on. Okay, my dear sir. Okay, see, let us solve the question which has come in GATE. So let us. Acha, everyone has understood this. Okay. Lambda, alpha, B, everything is clear to you all. Okay, no problem. So let us take one question, my dear sir. Let us take one question. So in this question it is given, let me draw the figure first. Wait. In this question, uplift pressure, or you can say simply hydraulic head at point E and D, at points E and D are given as, at point E and D are given as, my dear sir, okay, are given as 28% and 20% at, okay, wait, let me, given as 20, are given as 28 and 20% with a sheet pile, with a sheet pile at downstream end, with a sheet pile at downstream end of negligible thickness. That means this thickness of this sheet pile we have ignored. Okay, that is obvious, that I am not writing here in the question. Okay, if the sheet pile, if the sheet pile is also introduced or is also there, you can say if the sheet pile is also at the upstream end, is also at the upstream end, then find the uplift pressure, then find uplift pressure, then find uplift pressures, my dear sir, at point C1 and D1, C1 and D1. Now let's draw the diagram which is there in question. Now let us draw the diagram, sir. Okay, sir, this is the diagram which they have given in question. This is the diagram which is there in question. Okay, sir. I will easily understand because, sir, you have already told me everything. With your concepts, I have become champion. No problem. See here. Okay. This is your question of gate. No problem is there. So this is my, sir, this is my upstream file. My dear sir, this is my upstream file and this is my downstream file. Only nothing has been done. Only simplification of that composite weir has been done. Let me write down the points which are shown in the question. Okay, let me write down the points. Let me write down the point. This is your C1, this is your D1, this is your E1, and this is E, this is D, and this is C. This all are mentioned like this in the gate question. Okay. Also, it is given this is B, and obviously this will also be B because since you have simplified it, since you have simplified the entire floor, this is like this. 4 options are also given, my dear friend. 4 options are also given. Let me write those also. Let me write those 4 options also so that you are fully aware. 68 and 60%. B option is there, 72 and 80%. C option is there, 100 and 0 respectively, and then D option is there, 88 and what it is there, 88 and 70%. So everyone solve and immediately tell me the answer. I will wait for 1 minute. Then I will move to, yes, Sagar is absolutely correct. Then I will move to canal regulatory works. Okay. Very good, dear friends. Yes, very good, everyone. So let me explain once. I have already explained you. You all know the sum of E and C1 is equal to 100. Very good, everyone. You all know the sum of E and C1 is equal to 100, and the sum of D and D1 is equal to 100, as I have already told you here. As I have already told you here, you all can see this. Okay? No problem. So it is very simple, sir. At E it is given as 28. Let me write down. Sir, at C1 and E is equal to 100, and E is given to me, my dear sir. E is given to me as 28%. Then yes, sir, you are right. Then obviously 5C is equal to 72%. You are right. Very good. Everyone is correct. Let me solve it and we'll move ahead. And D1 and D, sum of D1 and D is equal to 100. That is also equal to 100. And value of phi at D is given as 20%, my dear sir. Then my phi D1 is equal to 80%. This is your second answer. So everyone is absolutely correct here. Everyone is absolutely correct. You all now are able to understand everything. So your answer will be which one? B option. Okay. Yes, sir. B option is correct. Now let's move on to next chapter. Which is your canal regulation. Okay. Wait. Now let's move on to next chapter, which is your canal regulation. Which is your okay, sir. Okay, now let's move on to next chapter, which is your canal regulation. Very good chapter, very easy chapter, and only definitions are there. Only basic definitions are there. You will understand everything, and from these topics, questions have been asked in previous year ESE. You will solve like this. You will solve everything like this. Okay, everything will be easy for you all after you have completed the irrigation. Okay. So now what will happen, my dear sir? Okay, so tell me, my dear sir, next chapter is starting. What is the meaning of that, and why are we studying it? What is there? What is the scope of syllabus? Let's discuss clearly. Now, the next chapter we are going to study is your canal regulatory works. Canal Okay, sir. Now you all know, dear friends. Now what you all have to understand is, see, you have constructed a canal, you are doing irrigation, you have constructed canal, and obviously there are a lot of things which you have to control. Sometimes you need to change the velocity, sometimes you need to increase the discharge in the canal, sometimes you want to stop the discharge, sometimes you want to remove the extra water. Okay, there are many things which you have to regulate from your side. Okay, so what happens, my dear friend? What is canal? If someone asks you, sir, what is canal regulatory works, you will say, we we construct some structures, or devices which have some specific function, so that we are able to get a hold, so that we are able to control, so that we are able to regulate three things, mainly three things. One is your depth of water, next one is your velocity of water, and the last one is your discharge. So I will say, sir, the the structures or devices which are constructed on my canal, okay, in order to regulate or control three things, mainly the depth, the velocity, and the discharge. Let me write down, and we will study all the structures which are important, which can come in exam. Let me write down the structures. Okay, the structures or devices constructed on the canal, which are constructed on the canal in order to regulate. Tell me what we have to regulate. In order to regulate, my dear sir, in order to regulate three things mainly. What is there? In order to regulate depth of water in canal, okay, velocity in canal, discharge in canal, okay. In order to regulate depth of water, velocity, discharge, and silt entering into canal, okay. Many things you can control. Silt entering into canal. You all can control everything. You all can control everything, okay. If these structures are there. One boy is asking one question. Let me answer that. Someone is asking that, sir, if piles are of different length, how can we find? That is not important, dear friend. If you insist, I can tell you, but that is not important. And I am very much sure that you won't be able to remember the formula also, okay? Even I am unable to mug up that formula. Even I am unable to mug up the formula. Even when I have taught this subject for 100 of time, okay? Then also I am not able to remember that formula. So I would suggest Shashi that forget it, don't worry. If piles are of different length, there are many mutual corrections also which are applied to piles, okay, for the slope, for many things are there which I think you should leave because that are not important. Otherwise that method of independent variable topic was in itself was 3 to 4 hour topic, okay. Yes, yes, you are right. Are you getting it? If you want I can tell you, but I think it is not important. I think it is not important and you should leave it, don't worry. Okay, so should I proceed further? So what I was telling, these are my canal regulatory works. What structures I construct, my dear sir? What structures I should construct, my dear sir? Okay. So these are the 5 structures we are going to study in this chapter. These are the 5 structures. First structure, my dear sir, is your canal fall. Is your canal fall. In exam, it is asked, what is canal fall? Okay, what is canal fall, when it is used, what are the factors, okay, all these things we'll discuss. Then we have to study canal regulators. Only 5 topics are there in this chapter, okay. Then we will study canal escape, canal escape, canal outlets, and then metering flume, we have to cover. All this you should just know what is that, what is this. Theory you have to cover and theory will cover and everything will, and you will understand everything and all questions will be solved, okay. So let's move. So first we have to understand canal fall, then regulator. Okay. So let's understand what is canal fall. Let's understand. First we are going to deal with canal fall, okay. Canal fall we'll understand first. So you have understood we are going to construct some structures. Some structures are there which we have to construct. Why? Because some structures we have to construct. Why? Because my dear sir, we have to control, we have to regulate, okay, we have to regulate. So first one coming up your way is your canal fall. Sir, how with the help of canal fall you control? Why it is constructed? Can you all see the image of canal fall? Okay, before seeing this canal fall, let me tell you exactly why canal fall is constructed. Whenever the natural slope of your, what you can say, natural slope of terrain or natural slope of the ground, okay? Whenever ground slope is very steep, very steep, then there are some problems. Let me discuss those problems very clearly. See here, suppose my dear sir, ground slope is very steep, and the designed bed slope of the canal is this, and the designed bed slope of the canal is like this, okay. Only this much slope is coming, let me write down, sir, this is your designed bed slope. And from where the designed bed slope of canal you obtain, you have studied the Lacy formula. I hope you remember Lacy formula, but I don't think you must be remembering it. You all do what? You all study things and keep on forgetting them. And you keep on studying new things and keep on forgetting the old things. You don't revise, I know. What was the formula of bed slope? F की power 5 by 3, F power 5 by 3, 30 to 40, Q power 1 by 6. You all remember? Okay, bed slope. So this is my bed slope which I need to provide in actual, which I need to provide for actual, so that discharge becomes constant or discharge achieves. So my discharge achieves what? Stability. So that my shape of the channel becomes constant. It becomes regime. It is in stable condition. Okay, it achieves stability. I have already discussed all those things. Okay. So suppose you have solved everything and designed bed slope is coming less and the actual ground slope. Okay, we are writing here if actual ground slope is very steep. If actual ground slope is steeper than this, I will write on that side only. Okay, is steeper than what? Designed bed slope. Then what you have to do? Then what problem happens? First understand that you have to excavate all these things. You have to excavate this area. Why? Because you have to design this area, this slope. Okay, so the extra soil you have to remove for above. Okay, that extra soil which you have to remove is known as cutting. You have to escape. Okay, you have to remove it. Are you getting it? And here you will see that since the bed slope has to come here, you will fill some soil here. You will fill some soil here. Okay, you will fill some soil here. So cutting and filling, this is your cutting. You have to excavate amount lot of soil and you have to fill it here. Okay, but this process of cutting and filling is very huge when you will go for long distances, because this is only here. When you will go for very long distance, you will see that this difference will go on increasing. And how much will you perform? If you want to construct a slope in a hilly area, then what will you do? You will not cut off the entire hill. You will not cut off the entire hill. You have to adjust. You have to adjust the terrains. Entire hill cannot be cut off if you want to connect a road. Suppose you have to connect a road from point A to B and a hill is there. And a hill is there. Okay. Then you will obviously not remove the entire hill. Okay, from between. What you do? You will do some management. You will do like this it will go, then road will go like this. Okay. You have to adjust. In a similar fashion, we are going to adjust here. In a similar fashion, we are going to adjust here that. Achha, now how will this? How will it adjust? How, sir, we will adjust? So listen very carefully. In order to be economical, what we do, we provide canal falls. We provide canal falls. How, sir? Kindly show me in the diagram how canal falls we provide, so that I am able to understand everything. See very carefully. Now with the help of the blue ink which I am going to use, we are going to draw canal falls. What you do, sir? You know that this is your bed slope, this is the bed slope, so provide this slope only. Provide this slope only in your canal. But after certain distance, what you do? Take a drop. Take a drop immediately. Take the drop immediately like this. Okay, immediately drop, and this drop is known as your canal fall. This drop in level is known as canal fall. Now, okay, take a drop like this. Immediate drop. Okay, wait. So wait, we have, you will understand it, don't worry. Take a drop here. Okay, take a drop here. Okay, drop here like this. Yes, now it is good. Okay, take a drop here and then again take the design slope like this. Then again take a drop here, and my god, steep slope is very steep. That's why problem is coming. I have drawn the slope very steep. This much of gradient is not even in hills also. Okay, that's why in drawing diagram problem is coming. no problem. Take a drop, then again provide the slope which is equal to bed slope. Then again take a drop, then provide the bed slope again. Then again take a drop, provide the bed slope again. Okay, so these are where you have dropped the level. Okay, where the difference has been adjusted is known as your canal fall. Acha, what is the benefit when you drop the level immediately? Sir, there is one benefit that now cutting filling has been reduced. Check this portion. Check this portion in this area. You can appreciate the fact only this much amount of excavation has to be there. Excavation is cutting of soil as you, and this will be filled in this area. This will be filled in this area. Okay, and this will become leveled. You can say, sir, this area will become leveled. This will become leveled. Okay, yes, this will become leveled, and if this will become leveled, this will equal to, and remember this green line will be equal to your designed bed slope of the canal. Designed bed slope of the canal. Okay, sir, now I have understood. Now for the first time I have understood exactly why canal fall has been provided. Okay, why canal fall has been provided. See, if you will consider this second portion, see, so much less excavation. See how much excavation you have saved now. See, only this much amount of excavation you have to do, and you have to fill that in that area, and you have to fill this in that area, and after this, okay, after this soil has been excavated from here and filled in this area, then this will become leveled and equal to the design bed slope which you need to provide. This will become equal to the design bed slope which you want to provide. So there will be no problem. Okay, so there will be no problem. I hope you have understood. Okay, yes sir, now I understand clearly that what is the function of canal fall. Otherwise, if you will provide this level at once only, then a lot of excavation and lot of filling has to be done. That I already explained you. Suppose you are providing this, and this is your, so you have to do a lot of excavation and lot of filling, which is uneconomical. And if you will provide, and if you will do all these things in bits and pieces, and if you will do it by parts, then obviously no problem will occur. And you can, okay, and you can easily adjust the difference. So I am writing, see, this is the real view. You all can see this is the real view. This is your canal fall. Can you see there is a fall immediately? Why? You all can see this is a fall immediately because your land is steep here. You all can see, land is very steep. That's why you have provided canal fall. So let me write down one line. Okay, let me write down one line. If natural ground slope, hope you have understood, kindly comment. If natural ground slope is steeper than, designed bed slope of canal, slope of canal, then the difference in level is adjusted. Okay, is adjusted by providing, or by provision of, by providing canal fall. Okay, hope everything is clear. Yes, okay, clear. This is your canal fall. Can you all see? Okay, has anyone seen this? Has anyone seen such type of canal fall anywhere? Anyone? Has anyone seen this? So this is your canal fall. I hope it is clear now. Yes. Has anyone seen canal fall? And it is provided at different intervals. After every interval, it has been provided. Okay, so you can remember this. There are many types of fall. Okay, there are many types of fall. Augie shape is there. Okay, Montague shape, straight glaciers, English. Many types of falls are there. But types of fall we are not interested in. Okay, now we will move to canal regulator. The second one. Sir, what is canal regulator? You all can see some diagrams here. Okay, I will show the real picture also, don't worry. Very good Sagar, very good Manish Malaya, everyone. So see, listen very carefully. Suppose this is your main river. This is your main river. Okay, or I can say this is your parent channel. Okay, parent channel means main river. and from here your canal is off taking from here. Suppose your canal is off taking from here, okay, like this. This is your off taking canal, I will say off taking canal. Okay, listen very carefully, otherwise you will not understand. Okay, what are the function, you should listen very carefully. So this is your main river and this is your canal of taking from here. So when you are diverting a canal from the main river, whenever you are diverting a canal from the main river, then what you have to do, you construct a regulator here, you construct a regulator on the main river, and you construct a regulator on the head of the canal, okay. Okay sir, yes, very good, this is your absolutely correct. This is your cross regulator. The regulator which is constructed on the parent channel is known as cross regulator, and this one, the regulator which is constructed on the head of the canal is known as your head regulator. Obviously it is provided on the head of the channel, obviously it is provided on the head of the canal, so obviously it is called head regulator. Okay, it is called as head regulator. Yes sir, I have understood this. Yes sir, I have understood this. Two regulators are there. Now listen very carefully. Acha, now you all can also see the diagram. See, this is your river. Okay, this is your main river. See, this is your main river. Okay, you all can see this is your main river, and this is your canal which is off taking from here. This is your canal which is off taking from here. So this structure is your head regulator, you all can see, and this structure which is constructed here is your cross regulator. See, in actual it is like this. In actual it is like this. You all must have witnessed sometimes. You all must have witnessed this. Maybe you must have seen this. You must have seen a small type of bridge, a small bridge from which you can cross the canal. Okay, gates are provided. These are your pier walls. Okay, these are your abutments, or you can say pier walls. Okay, this is your abutment. See, this is your regulator. This is your regulator. But how you can regulate? How you can regulate? Can you tell me? See, behind this water level is high. Behind this water level is high, and after this water level is low. Since you have raised the gates, more water is ponded behind. Okay, and when you will lower the gate, obviously water will flow in. Okay, so what is the function of regulator? Sir, function controls two things. Sir, what is the function of regulator? Regulator controls two things. Okay, regulator controls two things. Listen very carefully first. See, you all know that in canal two things are entering. One is your water and next one is your silt. Two things are entering in your canal. One is your water and next one is your silt. Okay, we want more water to go with proper amount of silt, but not much silt, because if much silt will be there, then obviously your canal will be carrying less discharge. Okay, so we want little amount of silt and little amount of water to pass. So in order to regulate, in order to control how much water and how much silt should enter from here, we have constructed a head regulator. Okay, clear? If someone asks you what is the function, let me write down here. What is the function of head regulator? What is the function of canal head regulator? I will say, my dear sir, only one function. It controls the amount of water and silt. It controls the amount of water and silt. Entering into the canal. I can control any amount, whatever I want. Okay, this is your main function. Of head regulator. Don't forget. Yes sir, clear? Okay, Acha, how silt is controlled? At the bottom of this, but at the bottom of this, okay, this is not your head regulator. I'm just telling you, at the bottom of this, silt excluder is there. I already told you yesterday that here, somewhere here, I have already told you, silt excluder is there. Parallel tunnels is there, which excludes lot of silt, and some silt only enters. I have told you yesterday, na? You all remember silt excluder? You all remember it? Yes sir. Now sir, tell me what is the function of cross regulator. Now dear sir, tell me what is the function of cross regulator. Listen very carefully. Sir, This cross regulator is provided across the river. This cross regulator is provided across the river. That's why cross is there. Then, because this cross regulator is perpendicular to the flow of the river, listen. Now, if here in your main river, listen very carefully. If here in your main river, water is very high, okay, and you have to provide same discharge. Suppose you are providing Q discharge in your canal, but what happened, sir? What happened, my dear sir? In river, discharge increased. Okay, in your main river, discharge has increased. So now what will happen? When discharge will increase here, we will open the gates of cross regulator because extra discharge has come now because of flood or anything. Sir, whenever in your parent channel discharge will increase, we will open the cross regulator so that the discharge which is going in the off taking canal is constant. Whenever extra water is there, we will divert it into cross regulator, and the discharge is going in canal will remain constant. Earlier it was also Q, now it will also be Q because extra water will be removed from here. This is the first case. And suppose in any case, if water reduces, your main river starts drying up. If in your main river water decreases, water level falls, then what we will do? You will close the gate of cross regulator. This is your cross regulator, and you will pond enough amount of water. You will raise the water level. Whenever water level is less, you will try to raise the water level by closing the gates of cross regulator so that entire water in the river is diverted towards the head regulator, towards the canal. Then also your discharge will remain constant, because whenever discharge is less or more, you are in a situation where you can control both the situations. So what is the main function of cross regulator? Sir, it helps in absorbing all the fluctuations. Which are coming in discharge, which is entering into the canal, Sir, now I have understood. Write down one line so that I am fully aware of it. Let me write down. Function of cross regulator. Sir, function of cross regulator is okay. Function of cross regulator is to it absorbs fluctuations or variations. Okay, let me write down it simply. It absorbs fluctuations or variations in discharge entering into canal. Okay, or you can say constant discharge in canal, or whatever discharge you want can be controlled with the help of cross regulator. Constant discharge and the amount of silt entering into canal can be controlled. One doubt is here. Malaya is asking, regulators are more efficient than weir. Are Malaya, you are confused now. Listen, this is your weir only. What I am saying, this cross regulator is your weir only. That weir thing which was constructed across a river was cross regulator. Weir was one example. Barrage was one example. If you provide gates here, barrage is, you will call it barrage. See, these are your piers. If gate is provided here, that is your barrage. If wall is constructed, then that is your weir. Are you getting it? Okay. Obviously, gates are better in controlling. That is your. So cross regulator is obviously. See, in this example, gates are provided. Gates are there or not? Gates are provided, so obviously it is kind of barrage. A small barrage is there. Okay, so it is similar to that. Cross regulator is nothing but same to weir and barrage. Okay, this you have already studied in canal diversion headworks, in which you try to divert. But whenever you are trying to divert, first you close the gates of cross regulator. Okay, it is similar. Divide wall will be there. Everything is the same. Okay, but it is called as cross regulator. If someone asks you what is cross regulator, you should know the function of cross regulator is to raise the level of water behind and then divert it here. Okay, no problem. It is similar. But we call it as canal regulators because the structures we have constructed, we will cover it in canal regulation. Okay, I hope we should stop here. We should stop here today, and we will proceed tomorrow. We will proceed tomorrow. I have tried to show you the images so that everything is more clear. Okay, and if you want to, tomorrow we'll be covering canal outlet. What is outlet? Different type of outlet, modular, non-modular. Okay, you must have heard everything. Sensitivity, flexibility, many parameters are there which govern outlet. Many things we will cover. We will cover canal escapes, water canal escapes there, that we will cover. Then we will understand cross drainage works. You must have heard about aqueduct, siphon aqueduct. Everything is very beautiful out here, and we will uh, study it tomorrow with full curiosity. Okay, see you all tomorrow at 7. See you all tomorrow at 7. Take care everyone. Take care everyone.